Good afternoon, everyone. My name is Jagan. I am research fellow in National University of Singapore, and basically I am from Science Center. So I am pleased to present my work on highly structurally sensitive and robust wearable strain sensor based on composite structure of carbon nanotube and 7 nanowires. For basically for health monitoring, like monitoring of human body, as Mr. Deep has shown, like work is quite similar to that one. So I'm going to present on this, and thank you for your time for this session. So basically these are the outlines. I'm going to introduce basically about the strain sensor and then experimental methods and results and discussion and conclusion, and finally acknowledgement. So it has been seen in last 1 decade, or like more than almost 1 decade, a growing interest in the flexible electronics in the area of wearable electronics, or particularly if we talk about the strain sensors. So basically strain sensor, what it do is basically detect any deformation, as you guys definitely know about it. So when it attached to the deformation surface or for like our human body, and when external force is applied in terms of the pressure, twisting, and stretching, bending, then this gives the some change in a significant change in the electrical out signals in form of resistance and capacitance. So these kind of sensors can be used for the monitoring of health and fitness in terms of the data analysis of the human body. So why strain sensors are now very important and can play a very critical role in upcoming society. So one is example is the, as you can see, the smart city, and smart city is basically part of the IoT. So in case of the like IoT, smart sensors can play very important role for the human health. It can digitalize the health service center. And if we further go for the infrastructure of a smart city in terms of data cloud platform and applications, it can be considered for like metering and transportation, lighting, location, and the well-being of the people, for example. And so this is the importance of the strain sensors, then how it can be very significant for it can play a significant role in our society. Now I'll go that what are the current challenges and why the importance of the strain sensor. So I would go basically few things like now elderly population is increasing, so their health monitoring is very important, and it is expected that like by 2050 or later on the elderly population, world population will be double. Is according to the NIH report published last year. And also, if we consider in case of the sports, then it can provide like training data for us. So we can work on the how improvement is required for the training and fitness purpose. And basically also the monitoring of the, it can detect the sleep pattern as well. And next, I would say that how strain sensors can be like useful for this kind of current challenges. So basically we will use the strain sensor and can work as a digital like tool. So it will help us monitoring of the people's health. And also it can be used for as an activity tracker for lifestyle changes. It can detect like sleeping pattern. So people can come to know that how their sleeping is affecting is, like for example, elderly people are not able to sleep properly. So suppose any stress like stress based device can give it their pattern of sleeping. So we can detect if person is okay or not. Also, it can play very important role in remote health care, digital health. So no need to visit multiple times to the doctors or hospitals. And this is also a market opportunity because important is the bridging between the research and the market and the society. So it can be useful. So it is expected like the growth of the market is expected for the fitness and health style in future would be like up to US $169 by 2030, and it is expected more. Okay, so this is the basically we can expect this market is based on the wearable electronics could be very huge in upcoming years. And opportunity, for example, our work from lab to market. So it's a great opportunity that we can develop something like advanced devices for both healthcare and fitness sectors by enabling personalized health tracking. The same thing I am like already discussed. So this is the importance, and it's a kind of an opportunity for the people who is interested in industrialization of the research. Now, I would say that I will go directly on my work, that how I have contributed in this area. Basically, as you know that there are modern like materials, like it's not modern, already investigated material, carbon nanotubes, graphene, maxine, silver nanowires, and conductive polymers, PEDOT, all are using for the application of strain sensors. But there are still some challenges with this individual materials. So there come complex material processing, fabrication, and also the aging, degradation. They degrade with the time. For example, silver nanowires degrade with time. So we cannot rely on the silver nanowire based wearable sensors that it can work for a long time. So there is an importance of the kind of enhancement of this material. So I have basically did some kind of a composite structure. So this is basically the how the like composite structure could be very important compared to the individual materials. So I have developed like carbon nanotube and silver nanowire based composite structure based strain sensor, as I chose very standard strain sensor structure. So if you see here, like first I deposit silver nanowire solution using the spray coating techniques. There was a certain distance as well as like how much quantity we can use in one go for make it repeatability of the process. And I use basically a soft mask, and then after this curing process, I use carbon nanotubes on it. So this is the composite structure of silver nanowires and carbon nanotubes based, as you can see here over there. And why I chose like composite structure, as we all are know that silver is oxidized with the time. So I have noticed, I worked in this particular strain sensor structure. I did the aging study. So as you can see here, silver nanowires for on one day. This is the SEM image took on one day. As you can see, very clear and sharp structure. And after like over 6 months nearly, they started to decay, oxidize. And when we coated carbon nanotubes on it, as you know, carbon nanotube is very strong. As you can see here, this structure. Carbon nanotube is very strong. It do not easily affect with the temperature and other environments. And I did a kind of a shielding of the silver nanowires. So as you can see here, this structure is after 180 days it still works. So these are the electrical resistance. This is for individual silver nanowires. After certain time, as you can see here, initial resistance started to increase. And for this composite structure, it remained constant. So it shows the stability of the sensor. So I basically focused on this composite structure. Before going there, I also tried the individual materials. As you can see here, this is for CNT based on PDMS substrate. This is pure silver nanowire based. Still is showing good property, but as you can see here, noise level is too high. And also, this is good enough. Silver nanowire is a good material, but problem is with this material is oxidation, because my purpose is to make a device which can work long lasting, like which can function for a long time use, and repeatability is also important. So this is composite structure. As you can see, very sharp signals over here. And these are some electrical properties I study on this composite structure. So finally, I choose this structure, this sensor I am showing here, like how that is worked. So I received gauge factor up to 79. Is not great, but still I would say it's a good like gauge factor when it's stretched up to 100%. And also on-off ratio was very excellent. As you can see here, Response time was 42 milliseconds. This was quite good. Sensor respond very quickly. Also, there is a one thing that is called hysteresis. It still is showing the hysteresis. When it's dropped to its original form, then it shows, but it's come to its initial resistance. And stability point of view, I tried my sensor at 50% strain, and number of cycles something like 5,000. This works very well without any problem. Shows the signal, clear signal from first cycle to last cycle. So it shows the stability. And I also made a comparison just to show that how my work is like compatible with the previously reported works. So this is basically for fair comparison. I compare my work concept called PDMS based substrates. So as you can see here, some all are like green. It means our is somehow considered as a good compared to previously other report. Although these materials are good, but here our case the advantage is of the aging as well as the performance and the stability. So still there are some sensors show higher strength, like for example 300 this one, and also gauge factor is quite high for this one particular single nanowires based PDMS, but it's like good compared to these other materials. And next, finally, I tried the main why this sensor was developed to monitoring the our body movements. So I tried my sensor on 3 structure, one on finger, second is on elbow, and third is on throat movement. So as you can see, very sharp signals and very clear, noise free almost is giving the signal. So I can say that my sensor is working very well without any like problem. So this is the conclusion. I consider basically it's a composite structure based sensor offering a superior performance and best in the class in composite structure based sensors. It show like high gauge factor, good response time, very fast, very quick, and it's improved the stability and durability. And more important, it can be considered as a prototype product which has the potential to create new jobs and startups, inspire the startups. So it's a quite good work. And this is acknowledgement for my team, Professor Lim, and my team like Dr. Chunfei and Lucas and Balaji, and there are other members. I'm not able to include their names, and NUS and Shine Center. Anyway, thank you so much.